I, a little bit about myself, but kind of before we get started is, I essentially have the job of running Twitter's open source office. So what that actually means is I'm the guy responsible for deciding what we actually open source. I also have a team of advocates that work for me and help kind of, evangelize our open source technologies. And I also unfortunately, have to deal with boring legal issues that currently, arise occasionally in open source land. But today, I'm going to talk to you a little bit about kind of the evolution of the Twitter stack, and a little bit about kind of our open source philosophy of how we kind of treat open source at Twitter. So, shameless self-promotion here, guys. Like, please tweet. Get a Twitter handle. Feel free to give any feedback. I'll definitely answer questions after the talk, after I see it. And plus, it's always fun to read criticism. So agenda-wise, I'm going to talk a little bit about the service itself and kind of the scale of the service of what we deal with these days. Then I'll talk a little bit about our open source philosophy, then do a little kind of history and evolution of the Twitter stack and kind of some technology choices that we made over time. Then I'll kind of go over some of the technologies we developed through that experience, and then I'll just wrap things up with some lessons learned and concluding. Oh, you're just taking that away.
No, I'm going to give it to you because they can't hear you.
You can't hear it? Seriously? All right. You think this will be better? Shit. Thanks, guys. How does this work?
Here you go. Other way.
Other way?
Yeah.
There you go. All right. That a little bit better, guys?
There we go.
Woohoo! All right. Let's put this here then. So, it's always good to start with, what is Twitter? How many people know what Twitter is? Pretty good? Yeah. All right, that's good. Nice, someone's tweeting in the audience, I like it. So it's always good to get a perspective of what the company, how the company views itself. And we essentially view Twitter as a public real-time information network that essentially connects you with, to things that you, find interesting or what we think is interesting to you. It's really simple, as that. The heart of Twitter is essentially tweets, and a lot of you are probably aware that tweets are, simply bursts of 140 characters, essentially, right? Technically that's around 200, bytes, but behind the scenes there's actually a lot more data that gets stored along with tweets, stuff like geo, link-related information, all that good stuff. But a common criticism is like, well, it's only 140 characters, but, I tend to, think that there's the old kind of like Shakespeare quote, like brevity is the soul of the wit. I think there's a lot of things you could do within the medium, and one of my favorite kind of examples is there's a crazy account that just tweets ASCII art. So Twitter art is legit. So just as an example of kind of what you could do with that space. So I think the constraint is a vehicle for creativity. So what's the scale of the service? So what's going on these days? So we're generally hitting about 500 million tweets a day. So if you do the math, that's about 3.5 billion tweets a week. If you do a little bit more math, that essentially equates to about 6,000 tweets per second, steady state. So it's a decent amount of traffic. The challenge though is kind of dealing with the peaks of this service, right? So if there's like a sporting event, people are going to tweet when there's like a touchdown or a goal, or Beyonce has like a baby bump on TV. People are going to tweet about that. But kind of my favorite example though is the Japanese. So a couple years ago, people in Japan had this brilliant idea of tweeting during an airing of a famous movie that was going to air the first time on TV. Right? It was Castle in the Sky, kind of a famous anime, if that's your thing. And so basically, when like the castle, in the movie was like being destroyed, they're like all going to tweet this at the same time. I don't know what like the direct translation is. I think it's like destruction or something, but let's just call it death to Twitter because it's a lot better in this case. So they ended up tweeting. Hitting 25,000 tweets per second, which is, well and above beyond what we normally handle. What's crazy is they also had this idea again not so long ago, and they did it again. And in 2 years, things have changed quite a bit, and pretty much hit 143,000 tweets per second, which is absolutely ridiculous. We've never seen anything like it. But the Japanese love their Twitter and love hey, let's all, like, God forbid someone, organizes something like this across the world, because that's going to be pretty painful. I would feel sorry for our ops team that day. Um, so now I'm going to talk a little bit about kind of our philosophy and how we kind of treat open source. As a company, I think we're in a bit of a unique position compared to other companies out there. But essentially, I could kind of distill our craft and philosophy into a few topics. So we'll start out with the first one, which is essentially like, by default use open source software. At least consider it on the list of things you do. So like, for example, like if we're writing like a caching component on Twitter, the first thing we would do is evaluate all the software out there, whether it's like Memcache, Redis, and before we'd even willing to go down the road of doing something custom, like you have to prove to yourself and to others in the company that you would choose a custom solution over what's already out there. So using open by default is totally the way to go. So in essence, by essentially doing this since the start of the company, pretty much the majority of the Twitter stack is all running on all sorts of bits of open source software. It's quite crazy. Dev.Twitter is running Drupal. Of course, OpenJDK and the JVM is there. We're using Git for source control. Rails is still kicking around in a couple places. Hadoop is being used for storage and batch job processing. MySQL for long-term storage. So there's stuff all over, in our stack, and it's pretty much all open source software. The other important thing is kind of giving back and open sourcing stuff. So like the first thing we've kind of done internally was kind of defining what Twitter's secret sauce is, and kind of once you do that, it's kind of easy to decide what you could open essentially to the public, since we're essentially a company that generates revenue from advertising and our service. The software is really just a means to the end, right? So with that in mind, it's kind of easy to decide what we actually want to open, because that essentially is the majority of our software. So like I said, if you know what your secret sauce is, then you could pretty much go through the philosophy of open sourcing almost all the things. And I think other companies that are more progressive, like GitHub, have a very similar approach to this. For specific examples, we had this internal tool called Blueprint at the time, and like I'm like a backend JVM guy. I like don't know this front end CSS stuff, and our engineers really wanted to open source this, and I was like, oh, okay, looks like some CSS toolkit. We did it, and Blueprint essentially became Bootstrap, and it became one of like the defining front-end technologies, I think, in the past couple years. So it's really easy to make those type of decisions if you kind of have defined what the secret sauce is within your company. Other stuff that we've kind of done recently is like we pretty much open sourced the majority of our front-end stack anyway. The stuff was coming down the wire anyway. Might as well open it. The other bit of our philosophy here is assume open. So, internally, anything that we're working on, we essentially kind of pretend that the software may eventually be open source. So, if you kind of develop that way, then essentially kind of raises the quality, I think, of the software you're developing, and also using some like reasonable dependency guidelines. So you're not tempted to potentially use like some GPL related software that may kind of screw your licensing decisions down the road. The other thing that we do is pretty much everything that we open, it goes to GitHub. Great folks, great service. Love the guys. Like, it's been amazing to see how quickly GitHub has grown over the years. So it just simply makes sense to open source your code at a place where pretty much the whole community exists. A special note about open source foundations, we kind of love those guys too, but we don't default to them in the beginning. We think that when we open something, our greatest goal is to actually build a community around it first, and the quickest way to do that essentially is at GitHub. Once there's kind of something that's built up, we may move it to a foundation like Apache or Eclipse as an example, but in the beginning it's important to kind of get traction. If there's no traction, then well, that maybe that project wasn't useful anyway. So that's kind of our note on open source foundations. The other thing we do regarding open source licensing, which people ask, we generally default to permissive licenses. We love MIT, BSD. Apache 2.0 generally is the default license. At Twitter, our philosophy around this is that the more permissive, the better. If your goal is adoption, just make it simple. You don't, anytime you involve lawyers, in licensing, it's generally a bad time. So a good way around that is just to keep the license as simple as possible. So nothing against lawyers; they're good people, but the less you deal with them, the better. So, and we're not. I don't think we're the only ones that have seen this. Like, if you kind of look at some trends in industry, there's been a kind of a, trends toward permissive licenses due to some of the reasons I've said. If it's just like something you don't have to deal with lawyers. It's a very simple license to understand. You could use it in commercial projects. You don't have to really do much with it. One of my kind of like coding heroes, Anti-Res from the Redis project, if you're familiar with that one, kind of went on this kind of like rant and about like licensing and his philosophy. I thought it was pretty interesting to get his viewpoint. But a couple things he said is like, I don't really care what people do with my code, nor if they release their modifications back to me. I just simply want people to use my code in one way or another. And his other like commentary was like, for me, other people making money out of something I wrote is not something I lost, it's something I've gained. So I think that's a good philosophy to have here. And then he kind of goes into this like, I'm having a bigger effect in the world if people are using my code and la la la. And then my license choice is BSD for him. So good for Anti-Res, great guy. The other thing that we kind of do that is unique, I think, for us is I've been involved with a lot of M&A related stuff at Twitter because we've been acquiring kind of small companies. But as part of our M&A discussions, we generally include open sourcing the software as part of the acquisition, especially if we're just doing a kind of like people acquisitions. I don't know if some of you are familiar that acqui-hire has kind of been a popular thing to do lately, so we've tried to include that in our M&A discussions. So, as a result, there's been some things we've done recently, like Red Phone, which was from Whisper Systems. So basically kind of, encrypt all your phone calls and messages and all that stuff, good stuff. So we just open sourced that and gave that back. Another one was Clutch that kind of happened recently. It was just an A/B testing tool. So no need for the software to die if you're just going to get the people, in my opinion. The other thing that we do is we pretty much measure everything at Twitter, from not only like the statistics around the service, but also around our open source projects in terms of our contributors, issues filed, and all that stuff. It's it's really the best way to operate. If you don't measure things, you have no idea what you're doing anyway. And this has been like a huge boon for us because if you're trying to recruit people, it's kind of nice to figure out like who's contributing to your open source project that is actually not an employee. Well, it's a great way to reach out to them. Finally, the last thing is paying it forward. So I think it just makes complete sense to support open source organizations that are critical to your business. It's the right thing to do. I wish more companies would do this, but hopefully in the future more companies will realize this and actually try to support open source organizations that are actually critical to their business. Because I mean, if the Apache Foundation went away, or the Eclipse Foundation went away, or the Linux Foundation would go away, there'd be a lot of sad pandas out there. And so that's essentially kind of our philosophy distilled. It kind of fits in a tweet, which I'm kind of proud of. So, that's it on that end. So let's get into a little bit more technical discussion. Twitter in the beginning, very simple idea. Jack Dorsey had this idea of like, hey, I want to be able to, send a status message, to my friends. Very simple. Have a public timeline, and so people could kind of view that or SMS it, whatever. At the time, not many users. Pretty simple stack of software. So the software stack was pretty simple. So, we affectionately called kind of the older stack the monorail. So it was essentially a Rails application where routing, presentation, logic was kind of all lumped into this Rails code base. Storage was all handled in simple MySQL master-slave setup, and that took us pretty far for a while. It's not so bad. 2007, they go to South by Southwest in Austin. It kind of starts blowing up. 2008 comes along. There's some growing pains. The fail whale starts becoming a lot popular. in the press. People keep giving us, shit that the service is going down. Even folks were calling us out for just like taking the service down ourselves as a joke, so people would write about us. Totally was not the case. That's not what happened. So, kind of as a band-aid, we're like, all right, we kind of have this monorail stack still kicking it. We mostly focused on just expanding storage because that was a huge bottleneck for us. So we basically temporarily sharded, our MySQL databases, added caching, so the service would survive a little bit longer. But we're getting to a point where essentially, the company was growing. There's a lot more engineers now. You kind of have like one monolithic code base has way too much, stuff in it. You gotta kind of get the like too many cooks in the kitchen type effect. So. But the band-aid worked for quite a while. 2009 hit. I think this was kind of the major inflection point in the service when things actually started to grow really fast. So we, at this point, we're like, oh man, like this stuff may actually, stick on. 2010 hits. There's the World Cup, right? So great time for the service. We hit our 3,000 TPS record. At that time, but it was a downer that pretty much like anytime anyone scored a goal, there was like a yellow card or like a red card, service would go down. Like it was just brutal, right? The press just wrote about it. It's like, God, it's not stable. Keep going down. So it was it was like an all hands deck thing too. So it was kind of it was just like it was kind of like demoralizing for engineers because you never want to be in a situation where you're just like fighting to keep the service alive. It's not a good place to be. So we're like, okay, it's time to kind of step back. We need to kind of look at things over and kind of think about how can we improve things. So, we step back. We realized that, we had this fragile kind of monolithic Rails code base. It was killing us. Like everything from managing, the database connections to the caching connections to rendering the site, presenting the public APIs was all kind of in the same, same bit of code. Just not a good way of doing it. We were essentially also just like throwing machines at the problem, hoping that keep scaling up machines would help solve things. But that gets expensive very quickly, unfortunately. And we're also what I like to call is we're kind of trapped in an optimization corner. So we were doing crazy things and trading off the readability of code to just eke out a little bit more performance. There's a lot of times where we're rewriting things as like C extensions for Ruby just to like get like a little bit more performance. And of course, that's just a terrible thing to do. Anyways, so and we also did crazy things like we call them whale hunting expeditions. So teams would kind of be organized and go look after a large-scale failure and figure out like what the heck happened. It was just not a good way of surviving as a tech company at that time. So like, all right, we need to re-envision the whole system. We've kind of survived now. What do we want out of this new system? So we knew we wanted huge infrastructure wins. We want more performance, reliability, efficiency, all that good stuff that you should have in a service. Also, we wanted to reduce the amount of machines that were running Twitter by about 10x. That was kind of our high-level goal. We also wanted to isolate failures in our infrastructure a little bit. So like, hey, if like the DM service goes down, it shouldn't mean that like all of Twitter goes down. So in distributed systems, failure is inevitable. So anything you do to isolate failures is a total win. And also just from like a good solid architecture point of view, we wanted to kind of have the code separated into nice discrete services instead of having a monolithic code base. So not only having like kind of code level isolation, we wanted something at the systems level too. So this is also when we started to evaluate our choice in Ruby. So Ruby was great. It got us to where we needed to be. So we started to evaluate our front-end serving tier based on CPU usage, RAM usage, and network usage. So we did that, and we looked at our Rails machines, and we noticed they were pretty much being pegged to the limit on computer and CPU and RAM usage, essentially, but only, but not the network bits. So like on the network stack, they were only handling about 200 to 300 kind of requests per host max. That's pretty abysmal if you work in, if you have some experience working in engineering. So we know we wanted to improve that because we could do a lot more on the network front. So, and at the time, Twitter's usage was growing a lot. So we're like, okay, It's going to take up a lot of machines to keep up with the current growth. So we need to kind of fix this fairly soon. Otherwise, it's going to get like really, really expensive to host Twitter. So at the time, thankfully, we had some teams internally experimenting with the JVM. So we had some folks working on search. So they decided to take advantage of Lucene, which is an amazing Java library for let's just say search-related stuff. And so they launched that, and it worked great. Like it scaled really well. The performance was amazing. We had another team that started to dabble in Scala and created our social graph service using Scala and particularly a graph database called FlockDB, which we ended up open sourcing, and they were really stoked about the performance. So we had a couple teams that were just like enamored with the performance of the JVM. We're like, all right, this is good, guys. We get a lot more requests per seconds on our hosts with the JVM. So we're like, all right, we're gonna go double down, and let's use the JVM for kind of future Twitter services. There was a lot of level of trust because if you're an engineer these days, you probably had some experience with Java, especially if you've been around the block. It's a very mature kind of platform. It also kind of intrigued us in terms of the polyglot possibilities because we're starting to mix Java, Scala. We had some Ruby at Twitter. We had some crazy neckbeards messing with closure and all sorts of stuff. So there was a lot of but the ability to like run all these different languages on the same VM that you only have to like tweak once and deal with once across your data center is awesome. So we're like, all right, this is it. Let's go for it. So we started to decompose the monolith, and we started pretty simple. We created services kind of based on our core nouns. So there's a tweet service, handled tweets. There's a user service, handled users. Timeline service, handled timelines, and so on. So we kind of went through that process and did it very gradually, and we eventually got to the point where about that. Damn. So we eventually got to the point where we had a nice routing layer that was essentially handled by one component, which we affectionately called TFE, Twitter Front End. It's most, for those of you that are familiar with Netty, it's mostly based on Netty, which is an amazing networking component that's Java-based, essentially. So it serves as a reverse proxy. We went through the process of decomposing the monorail kind of one by one, piece by piece, and had wonderful services for each important bit of Twitter. And that's kind of how things worked out. And pretty much, today we're at a point where the majority of Twitter is now running on the JVM. Some aspects of the monorail still exist, but in the long term, it'll be completely gone. But this gradual way of decomposing Twitter worked out really well for us. So I don't think you guys have seen a fail well in quite a while, at least not as much as before. So how do we kind of develop aspects of this stack? So we'll take a peek at some of our technologies. So for the kind of old adage of concurrency is hard. It's not the easiest problem in the world. So as each team was kind of decomposing the monolith and into individual services, they were kind of taking different approaches to the problem of concurrency. Each team kind of had different failure semantics, like what happens if you have to deal with like back pressure and all that wonderful stuff in distributed systems. So this kind of informed us that, okay, if all these teams are kind of solving something similar but taking slightly different approaches, it's time for a common library to actually implement these things in so they could be reused by the team. So we ended up working on that, and we had a team that basically created this wonderful Scala-based library called Finagle, which powers things like Foursquare and Tumblr and other sites, but I could talk about that a little bit later. But essentially, Finagle essentially takes care of things like service discovery, load balancing, retrying connection pulling, stats collection, distributed staging, all that like stuff that you don't kind of want to necessarily deal with or handle yourself. So it's all handled by the library. So all the engineers working on the service can only focus on the actual service itself and not worry too much about all the kind of failure domains and all the bad things that could potentially happen with your service if like a data center blew up or there's an earthquake in California somewhere. So, and the API was taking advantage of some modern functional aspects in the Scala language. So it's pretty easy to compose your services and have them depend on other services. So it's really solid stuff. Code's all kind of available, open source. Lots of companies are taking advantage of Finagle these days. The other thing that we needed to do is essentially, logging, tracing, kind of important. So when you start decomposing things into all these little bits and little services, if one fails, it's a little bit difficult to understand why it failed and what dependency kind of screwed up. So we basically created Zipkin to basically handle tracing of each service. So for example, if like the DM service went down, you could basically go trace the logs of the DM service and quickly have kind of an overview of what took the longest to happen, what took the longest as part of that request to happen. So like, hey, did the MySQL service, the query took the longest, your query was broken, so go look at that. Or did there's a GC pause for some reason, so you could look at the JVM. So it pretty much helps engineers focus on what the actual scaling problems in for each service. So it's a really sweet piece of technology. For those of you familiar with the Google Dapper paper, it's actually kind of based on that. So we kind of took Google's wonderful research and kind of re-implemented it our way. The other thing that eventually happens is you start generating tons of data and logs and stuff, and you start like chucking them in Hadoop or whatever your storage is of choice. If I don't know how many of you actually had to write like a MapReduce job in your life or like a pig script, like it's the worst, right? So we basically like, okay, we need a better DSL of dealing with writing. Nice. we need a better way of kind of like querying data across our kind of Hadoop cluster. So we created Scalding, which is a very like concrete, nice DSL for writing Hadoop jobs. Highly recommend checking out this library if you ever have to write stuff. It takes advantage of like the Scala language, so you have nice like compile safety and all this good stuff that you don't really have in Pig. It's terrible. The kind of last, kind of really most important piece I think of the technology stack is before I was talking about how we're throwing machines at the problem, right? We're like, oh, let's just keep adding machines and hope that Rails doesn't fall over. We knew this was not the right solution, and the way we kind of had things set up, and a lot of other companies kind of do this too, is you generally have like static partitions for like, hey, this is your Hadoop cluster, here's your caching cluster, here's whatever, here's your whatever cluster, and what happens is all these different clusters have different usage profiles, right? So your Hadoop clusters generally handle batch jobs, right? So you have a job that like counts tweets in Australia today, right? And so that goes off and then it's done. And then so your utilization, you kind of have a box that's not being fully used here, right? So, and stuff like Memcache or Redis kind of have like more of a steady utilization profile. So we're like, we have all these machines and there's like a lot of waste going on in our data centers. Like, there's got to be a better way, right? Someone has had to like, think of this, right? There was someone that has thought of this. So like, like with some things, Google's had this problem kind of figured out for a little while, right? They have a lot of machines, and so they wrote an excellent paper on this concept that's called a data center, kind of as a computer. And the way they kind of So stepping back a little bit, so we found this like, oh, this is awesome. Then we also looked at like, is there like any universities also doing some crazy research on this? And we eventually found one, Berkeley Amp Lab, great lab, and they were starting to do some actual like implementations of this stuff at the university. So we actually decided to talk to them, work with them, and actually like bring them on as employees and work with the technology that developed and actually like open source it so other folks could actually get involved and take advantage of the technology. It was kind of a fun, great way to work with a university that was doing some cool stuff. So technically speaking, the way it works, for those that you are familiar with a little kernel things, is essentially like, machines are pretty beefy these days, right? You have machines that have like, tons of RAM, 30, 32, 48 gigs of RAM. You have cores, 16 cores, 32 cores, whatever. Essentially what Mesos does is it uses C groups, essentially. So you could essentially, via resource isolation, say, hey, this processor framework only has access to like these 2 cores, right? And you kind of max out how much usage you have of kind of each machine. So basically, what you end up doing is you have like Memcached and Redis and your Hadoop cluster all running kind of on the same machine, but kind of isolated from each other. So it's great. It's kind of simple type concept on the service, but actually quite complicated, under the covers. And so kind of Mesos does the kind of hard work of dealing with that, and it's working out pretty well for us. So what it ends up doing, if you kind of look at the numbers, it pretty much reduces your capex and opex. Essentially reduces latency because everything's kind of running on the same machine. So there's like less hops to kind of deal with, and of course it takes advantage of all CPUs and RAM available on the computer, so there's not much waste. So to me, it's an awesome technology, and I kind of see the future direction of folks moving towards this because it makes no sense to waste these crazy huge machines you have these days. So at the end of the day, how did things turn out? Like that we did all this. So not so bad. So like if we kind of do like a little picture here, like in the beginning. Okay, site success was not so amazing. World Cup was really bad times, and now, now that we're pretty much off the monorail, things have been, steady. When the crazy Japanese folks decided to all tweet at the same time, there was no ops people were called. It was like, oh, okay, no problem. So things are super stable. All the performance around our API endpoints from moving to the JVM have been smoking fast. At the end of the day, I think we ended up reducing, our original goal of reducing the machines to run Twitter by 10x actually happened. So it's been awesome. In terms of growth today, we've sustained ourselves pretty well. We're over 2,000 employees worldwide, kicking it well. Half of them are engineers. That's kind of always been our philosophy at Twitter, is that we're kind of try to keep that 50% split to keep the company sane, in my opinion. We have over 230 million users, 100 plus open source projects, a variety of stuff that we've opened up these days. A huge portion of our user base is on mobile, which I guess that's what the kids use these days. They love their phones. And we support a ton of languages. So it's essentially where we are today. So let me wrap things up with some concluding thoughts before I guess I open the floor to questions. So number one, we wouldn't be able to get to where we are today without embracing open source technology from the beginning, like Rails and MySQL completely helped bootstrap the service, and we didn't really pay much. We pretty much paid nothing to use these amazing technologies that were available. And as we evolved and we had more traffic and usage, we embraced other wonderful technologies like the JVM, OpenJDK, and all that good stuff. So there's no reason not to use open source software when you can. And there's no shame in learning from what your peers are doing or what's going out there in research. Mesos would have not happened if we did not work out with our wonderful friends at Berkeley Amp Lab. So. And the other important lesson here is, it's open source is not like a zero-sum game. So don't only be the leech. So give back what you can to kind of enrich the ecosystem and make it better, make things better for everyone else out there. Lesson kind of number 2 in our transition was, incremental change always wins. It's tempting sometimes to kind of just kill everything off and start from scratch. But it sounds great, but in theory, but in practice, it's a little bit more difficult. So for us, the ability to slowly move off the monorail and decompose things one by one was a total win. So kind of the final lesson is this whole data center as a computer. I think is kind of it has been a huge win for us, and I think is kind of one of the future directions for infrastructure-related software. It's the most efficient way to use, your infrastructure. It saves you money in the long term. I didn't have time to kind of discuss the programming model for Mesos, but it's a much better way for engineers to think about developing their software, for the data center, because they're essentially, specify, their job, and they specify it in terms of the resources they need. They don't have to like deal with messy host names and stuff like that. Mesos kind of figures out all that and distributes the workload based on what they need, based on the resources they need. So, other than that, I think that's essentially the end of my talk. So I hope you guys kind of learned something new today. Feel free to tweet at me after the talk, or now if you like, and I'll do my best to answer your questions. Feel free to follow the work of Twitter's open source office at TwitterOSS. I'll post the slides online after this talk, and they'll have a bunch of resources and all that other good stuff available for you if you want to check things out on your own. Other than that, thank you. So let's do questions. Oh man. Okay, let's start with you because I saw you first.
Okay. So you mentioned when you guys introduced Finagle and Zipcan, that you needed some kind of common library to erase some of these pain points of different teams.
Correct.
Doing things in different ways.
Yeah.
So I have kind of a two-part question.
Yeah.
Part one is, was it hard to get all of your developers kind of on board with using this new library? And then part two is, do you see like similar problems coming up that require you to do the same thing and introduce a library that now your 1,000 developers need to use?
Yeah, so the question was, so when we introduced, let's say Finagle, we introduced a new library, how was it migrating people to use that new library? So in the case of Finagle, it was a little bit challenging because, historically the company's, was a Ruby shop, right? Lots of Rails usage, and we're moving to the JVM, and Ruby people are like, fuck Java, pretty much is like, so it took a while. We basically implemented training, and so we trained people, did weekly courses on Scala and Java and all that stuff. So basically, it took a huge investment in training to get people up to speed. The library itself was quality, but the engineers willing to move to it, it took a while. And I think your other question was around do we see something like this happening currently? We kind of have a similar problem with these days you look at mobile and tablets, the usage has just been ridiculous, and the number of people using the desktop has kind of been going down. So we kind of had an issue of crap, we need Android engineers, iOS engineers. So we had to implement programs internally to actually train existing engineers on Android or iOS versus actually going out and finding people. It's much easier to train your existing folks at the company and give them new opportunities to work on stuff than trying to deal with the limited pool of talent. So in the end, the investment is in education, and we kind of have a great program internally called Twitter University, which is a group of people that are essentially dedicated and focused on training our employees on things that we need. So, yeah. Oh man. No. Let's go. I'll get you guys in back. Let me do this fine bearded gentleman. So
if you've got on the server side, if you've got all of your machines running at good utilization, how do you handle peaks?
Over provisioning. So you always over provision the amount of machines that you have.
So you have some machines sitting around idle.
Yeah, some. So so when the Japanese guys are like, hey, let's all tweet at the same time because it's funny. So it handles that. So, yeah. Yeah. No, the first time was hilarious because when first time they did it, we people go in the office the next day and it's they're looking at we have our internal tool that measures everything with Bird Brain, right? And so Bird Brain's she has this ridiculous peak, and we thought it was a bug at first, we had no idea, and then eventually we thought our logging infrastructure was hosed, but we eventually Googled around and talked to our Japanese colleagues, and they kind of informed us of what happened. So, and the second time they did it, we knew the second time they did it, we knew it was coming, but the infrastructure is pretty solid at this point. There was no crazy emergency to deal with. All right, let's get the gentleman in the back, right there. You. Yes. Yep. Yeah, we're using OpenJDK. Right now, I think it's 6 for the majority of things. We're looking to move to 7. So slowly but surely. We forked OpenJDK a little bit, mostly to improve things around GC logging and stuff like that. We're working to eventually get those contributions moved upstream, but if you ever try to contribute to OpenJDK, it's a bit of a pain. Oracle's not the friendliest. They're good people though. All right, sir, right there.
Did you move completely away from Hadoop?
What's up?
Did you move completely away from Hadoop?
No, we are using Hadoop heavily. So all our analytics infrastructure is all on Hadoop. So all batch jobs related are done on Hadoop. We also have Storm for kind of real-time processing, but like we have a ginormous Hadoop cluster, like I think 100 plus terabytes a day ingested of data. Like it's a lot. So it's a beast. Any other questions? Yes, gentleman right there.
So Twitter has about 1,000 engineers.
Yes. Why do we need 1,000 engineers?
How does it break down percentage-wise on what they're working on?
So that's a great, in terms of like with the different teams. So, oh man. So the good thing about when we started decomposing, Twitter into different services, you had teams kind of dedicated to each service, right? So instead of kind of having like a mess of engineers on this, crazy code base, you kind of have like a team responsible for like, the DM service, team that owns a DM service. You have people that own the tweet service, the user service. We have a team dedicated to security, right? A bunch of engineers that all they do is deal with, inquiries around people who thought they have hacked Twitter or actually have, and kind of deal with that. There's teams dedicated to like mobile-related, development, Android guys, iOS guys. And we have analytics guys. We have like your crazy like neckbeards writing your R scripts and all these crazy things. So it's a mix of folks. So a lot, most people ask like, why do you need 1,000 engineers? But if you get to a certain size, there's a lot of moving pieces. There's a lot of things you have to do around analytics, and it becomes non-trivial just to run the service, as I hope you saw. Any other questions? All right, someone in the back there. Yes, you. Say that again? No, they are not. The majority of our employees are in San Francisco, so it's kind of headquarters for us. I think there's at least 1,500 people in San Francisco, but we have offices all over the world. We have an office in Seattle, New York, Boston, Chicago, London, Tokyo, and a bunch more smaller outposts that are mostly like sales related outposts. But those are the offices I mentioned are mostly engineering. Any other questions before I guess we go drinking at GitHub? GitHub's little soiree. Yeah, one more question?
Yeah. So you do a lot of stuff on the JVM. I mean, do you guys use Eclipse? Do people just use whatever they want?
So the question is like what kind of tools we use. We do a lot of work on the JVM. Our philosophy generally is you use what is best for you as an engineer to get your stuff done. Internally, it's a mix of like Eclipse, IntelliJ, crazy old school people still like hacking with Vim and Emacs and all that good stuff. So it's a mix of both. So we do have some stuff that gets people started, like if they're using like Eclipse or IntelliJ, there's some stuff that helps bootstrap them, but we don't it's our philosophy not to dictate tools on folks. So use what you need to get the job done. Any other questions? Well, guys, hope you guys learned something new. So go enjoy free booze from GitHub. Thanks.